Okay, in this example, we're going to do our guided practice, and I'm going to walk you through this a little bit more than I normally would because it is fractional, and I know many of you really are not a fan of fractions. So again, what we're going to do is we're going to look for parentheses, and there are none for us to distribute. So then we're going to try to get rid of our fraction. So the first thing I need you to do is take your two denominator values, the two bottom ones, multiply them together, and that's the denominator that you're going to use to set up your new fractions. For your first fraction of 2/3, you're going to say, what did I multiply 3 by to get to that new denominator number? And whatever you say is what you multiply the top or the numerator value by. The second fraction, the divide by 5, you're going to say, what did I multiply 5 by to get to the new denominator value? And that's what you multiply the top number, the 3, with. At this point, you should have the same denominator values, different numerator values, so now you're going to multiply every single term to get rid of your denominator value, your fraction. On the left-hand side, the denominator will cancel with that term that you multiplied to every term by, and it leaves you with your numerator term only. And you're going to do that with both fractions on that left-hand side. On the right-hand side, you're just going to multiply that 4 times your denominator value. So at this point, we shouldn't have any fractions at all left over. And what we're going to do on the left-hand side is combine similar terms. And then because we have a variable term on one side and a numerical term on the other, we're going to divide the coefficient away from the m term. And then from there, we're going to simplify our answers, the fraction from what we get. So let's look at this example. Again, the first number that both 3 and 5 go into is 15. So that's the denominator value that we're going to use as we set up this problem. So for each fraction that we see, that's what's going to become the bottom. From there, we have to say 3 times what got me to 15. So it was multiplied by 5, and that's what I multiply the top by. So my equivalent fraction to 2/3 is 10/15. Moving to the second fraction, I'm going to say, what did I multiply the 5 by, which is a 3, and I do so to the top. So an equivalent fraction to 3/5 is 9/15. At this point in time, we want to get rid of all of our divide by 15, so the opposite of divide is to multiply every single term by that number in the denominator. Now remember, on the other side, that the 15s are going to cancel. That's why we multiplied every term by 15. And it leaves me with just my numerator terms. On the right-hand side, I end up with 4 times 15, which is 60. So then if I combine similar terms on the left-hand side, 10 m's take away 9 m's leaves me with 1 m. And then you can stop there because it's a positive 1 m, or you can divide that 1 away, but you still get m to be 60 for our final answer. In our next example, we have decimal equations. So again, as we look at this particular problem, I'm going to set you up with your line through the equal sign, but we're going to handle this pretty much just like we did before with the other solving equations. So if you see parentheses, distribute. If you see fractions, visual fractions, get rid of them. If you can combine any similar terms on one side, do so through addition or subtraction moves. Box your variable terms. Move your smaller variable term to your larger through addition or subtraction moves. Move your constant term onto the opposite side, also through addition or subtraction moves. So now we should have variable term on one side, numerical term on the other side. So the last thing we're going to do is to divide our coefficient, and we're going to get our final answer. All right, so let's look at this. If we start this problem on the left-hand side, We have 3.8w plus 3.2, and as we look at this, we have no parentheses. On the right-hand side, though, we do. So we're going to distribute. So we're going to go 2.3w, or times w for 2.3w. And we're going to go 2.3 times, and I'll use parentheses because of the decimal, 4, and that gives us 9.2. So there's our first action that we had to take. Visually, we do not see any fractions. I can't combine similar terms on either side, so I'm going to box my variable terms. Now the smaller term is the 2.3, so I'm going to move that to the 3.8, and because it is positive right now, I'm going to subtract it across. And remember, so again, as we combine 3.8, we're going to subtract 2.3, we're going to line up our decimals, and we get 1.5w. Building off from there, on the right-hand side, those w's canceled. All I have left is 9.w. So now we're going to rebox our variable term. We're going to move our constant term away from the variable. So because it's a positive 3.2, we're going to subtract 3.2. So we have 1.5w equals, and again we're subtracting our decimals, so we actually get here 6. You can keep it as 6.0 if you want. That is a choice that you make. Last step, now that we have variable term on one side, constant term on the other, we're going to divide by the coefficient of the w, and which is 1.5, and we end up here with 4 as our end answer. So in this next example, I need you to pause the video, try the problem yourself, and then go through and check your answers with mine. I am going to be using the LCD process, so I'm not going to multiply all of these denominators out, but if you do so, please have me check your problem. Our answers should be the same in the end result. So pause your video, and here we go. So in order for you to use the LCD result, circle all of your different denominators, and there are 4. Going to look at the larger number and say, can 5 times a nice natural number get to 10? The answer is yes, 2. Then you can ask, can 6 times a natural number get to 10? The answer is no. So 10 is not my LCD. So then I move to 10 times 2, which is 20. Does that work for 5? 5 times 4 is 20, that works. Does it work to 6? It doesn't. So then I go 10 times 3, which is 30. Does that work for 5? Yes. Does that work for 6? Yes. Does that work for 3? The answer is yes. So the number that I'm going to use in my denominator is 30, and that is in fact the first number that all 4 of these terms go into. So that's what I'm going to be setting up as my denominator. If you multiplied all of your single terms together, then you would have had 30 times 30, which would have been 900, should have been your denominator. And that's quite a large number. Notice the difference between these. You might have said just 30 automatically because there's a 30 on the left and there's a 30 on the right. And that's also another way to find this LCD process. So now that we've done that, what we're going to do is make our equivalent fractions. Again, we take the 5 from the first fraction and say 5 times what gets us to 30? And that's a 6, and that's what you multiply to the top number, the 2, as well. So our equivalent fraction to 2/5 is 12/30. You come to the second fraction, the 6 is going to be multiplied by 5 to get to 30. So then my equivalent fraction from 1/6 is 5/30. Moving on to the other side, doing the same process, you say the 10 times the 3 is what gave me to 30. So multiplying the numerator, an equivalent fraction is 9/30 to 3/10. And then the last fraction, I have to multiply top and bottom by 10 so that the denominator can get to 30. 1 times 10 is 10. So 10/30 is an equivalent fraction to 1/3. From there, what we're going to do is multiply every single term by 30. And there are 4 of them that we had. And as I multiply, notice again that the 30s that I multiplied are canceling with the 30s that I see in the denominators. Ultimately, what we're being left with here are just the numerical numerator terms. So I have 12k's plus 5 equals 9k plus 10. So at this point, all fractions are gone. We're down to regular basic solving. Box your variable term. We're going to move the smaller to the larger, so we're going to subtract 9k. That gives me 3k plus 5 equals 10. Rebox your variable term. I'm going to move my constant term away from my variable term. Gives me 3k equals 5. And please, again, as we divide our coefficient away from our variable term, don't be afraid of fractional answers. My solution for k is 5/3. So I like to keep it as an improper fraction, a top-heavy fraction. If you want to make it a mixed fraction, I would never call it wrong. In this case, though, it is a decimal that repeats, so it's a rational number. But because it repeats, it's best to keep it in fractional version as opposed to a decimal. Our last problem is our self-check. Again, pause your video and then try your answers with me. So again, no parentheses, no visual fractions, even though we do have decimals, so we're not going to worry about that. We're going to try to combine similar terms, but we can't on either side. So I'm going to box my variable terms, and I'm going to move my smaller to my larger. And as I do that, 0.4 is smaller, so I'm going to subtract it because it's positive. And then just like adding and subtracting polynomials, 1.3 take away 0.4 is 0.9k's. Rebox your variable term. From there, what we're going to do is move our constant terms away. So I'm going to subtract 1.2 to both sides so that the 0.9 is all by itself on the left-hand side. And on the right-hand side, we have signs that are the same. So I'm going to add the numbers, and I'm going to keep that sign. Now what we're going to do is divide the coefficient away from the k, and so that k is all by itself a positive 1k, and as you divide 1.8 divided by 0.9, you get a nice whole number 2, but one negative is going to make that solution for k a negative 2. This concludes our lesson on fractional and decimal equations. I'm sure you'll have a lot of questions for me, but please write down specific questions so that I can address them when we come together. Thanks again.